Today we'll be talking about graphs, specifically ordered pairs. Those are how we can identify points on a graph. So a coordinate plane. I want to make sure we understand the words are involved. First of all, visually, you've seen coordinate planes before. This is what they look like. That's a coordinate plane. But a coordinate plane is used to locate coordinate points. Now, if you want some real, points. Some real language lesson here. Co means together or two, because every point will have two numbers. Ordinate is a word that has to do with location. So it'll take two numbers to determine the location of these points. That's where coordinate comes from. Co is because there's two numbers that will lead us to the location, ordinate points. The x-axis is the horizontal number line. And so you can probably figure out the y-axis would be the vertical number line. So if we want to go any farther, I'll just label them down here. The x-axis is this horizontal number line. So this is the x-axis right here. Normally it's just labeled with an x, so you know it's the x-axis. Now the vertical one, going straight up and down, this is the y-axis. And it's usually just labeled with a y, but just for identification. So the x-axis is horizontal, the y-axis is vertical. And the origin is the point at which the axes, that's plural of axis, so this is not talking about the things that chop wood. It is spelled that way, I think, but this is the axes, meaning the plural of the word axis. Is the point at which the axes or the number lines intersect. So that is this point right here. It's at 0, 0. It's called the origin. They will often have an O. It looks like a 0, but it's actually like an italic O right here, just to make sure you know that's the origin. So you may or may not have known I was actually working ahead by labeling those, because I'll put it here, so if you need to pause and write those down, feel free. But the next step is to label the coordinate plane below. And we've done 3 of these already. We've labeled the x-axis, the y-axis, there and there, and the origin, the point where they meet. Now they want us to label each quadrant. So if you think about it, these 2 lines cut us into 1, 2, 3, 4 different spaces. So those are the quadrants, quad meaning 4. So there's 4 spaces, quadrant. And the one in the upper right is quadrant 1. And you have to use Roman numerals when you're labeling the quadrants. And then for reasons I don't know, they go counterclockwise. So this is 1, then you go counterclockwise. This is 2. This is 3. And the last one is 4. So that's I, then a V in Roman numerals. So 1 starts in the upper right, everything's positive up here, positive x values, positive y values. Then it goes counterclockwise. You can almost think of it as it makes a C for coordinate plane. I don't know, just thought of that on the moment. So rules for graphing ordered pairs. An ordered pair consists of 2 numbers. I'll give you a hint, they call it a pair. And it's used to locate any point on a coordinate plane. So in general, they look like this. There's an x value, then a y value. Now these will normally be numbers. This would be called the general way to write it, or the generic way. But the first term in an ordered pair is always the x value. Always put the x first. The second term is the y value. So that's all the time. It's alphabetical. X and y are in that order in the alphabet. They're also in that order in an ordered pair. So we're going to use that to graph these ordered pairs. So first A, 6, 8. So the first number tells us how far to the left or to the right to go. If it's positive, that means you go to the right. If it's negative, that means you go to the left. So A is telling us to move. One thing I forgot to say, for all points you are graphing, you always start at the origin. Always. So I start at the origin right here, and I go to the right. 1, 2, 3, 4, 5, 6. Then the second number, 8, tells me how high or low to go. When it's positive, we go up, which makes sense. Positive go up, negative go down. So now that we've gone over 6, we go up 1, 2, 3, 4, 5, 6, 7, 8. And normally you will not have to label these, but just since we're first starting with this, I'm going to, just so we know which is which. That is point A. Okay, now B, notice it has both negative numbers. So when the first number is negative, that means you go to the left instead of the right. So as always, I start at the origin and go left, 1, 2. And then the negative 3, as the second number, tells me to go down 3. 1, 2, 3. So that's point B. So again, the first number tells you whether to go left or right. Positive means right, negative means left. The second number tells you whether to go up or down, and how much to go up or down. So that means up 8, that means down 3. So C tells us to go to the right 10, and then down 4. So I start at the origin, always, go to the right 10, which you can see 10 labeled right there, and then go down 1, 2, 3, 4. That's point C. D tells us to go left 5 because it's negative, so we go to the left 5, and because it's positive, go up 7. So we go left 1, 2, 3, 4, 5, go up 1, 2, 3, 4, 5, 6, 7. And one thing I haven't pointed out yet, you can always see these numbers are aligned on the number line. So look down here, well that has to be negative 5 because it's between negative 6 and negative 4. This has to be 7 because it's right in between 6 and 8. So that's how we can graph ordered pairs. Now we're going to go in reverse on this one. We're going to try to identify the point. So here they gave us the ordered pairs and we graph the points. Here they gave us the points and we're going to try to identify the ordered pairs. So let's start with A. Start at the origin, and we see to get to A we have to go left. We have to go left 1, 2, 3, 4, 5, 6, 7, 8. So you can see right there it's aligned with negative 8 on the x-axis. So our first number in the ordered pair will be negative 8. And our second number tells you how high or low it goes from there. So if we're at negative 8, A requires us to go down 2 spots. So negative 2 is our second number. So our x value is negative 8, our y value is negative 2. And please be aware, to write an ordered pair, you must put parentheses around it. That's a requirement. It's not an ordered pair if you don't put parentheses around it. You also must put a comma between the two numbers. Okay, B, we start at the origin always. We see we have to go to the left to get to B, so we go left 1, 2, 3, 4. So it's at negative 4. So we go left 4, then we go up 1, 2, 3, 4, 5, 6, 7, 8, 9. You can see it has to be 9 because it's between 8 and 10. So 9 is our second number. So B is at negative 4, 9. Now for C, we have to go to the right. So we go to the right just 1. So it's at positive 1. We just go right 1, and we're lined up with C. So C's ordered pair begins with 1, because that's how far right we have to go to get there. Then from 1, we go down 1, 2, 3, 4, 5, 6. You can see it's aligned with negative 6. So negative 6 is our y value. So it's aligned with 1 and negative 6. So it's 1, negative 6. Last one, D. We start at the origin. We see you have to go to the right. 1, 2, 3, 4, 5. So we have to go to the right 5 or positive 5. So our first number in D is 5 because we have to go to the right 5. Then from there we have to go up 1, 2, 3. So if we go up 3, our y value, our second value, is 3. So the first number tells you how far left or right you have to go. That's the x value. The second number tells you how high up or down to go. That's the y value. All right, last section of these notes, relations. So a set of ordered pairs, notice not just a single ordered pair, but if we start grouping them together, even if it's just 2 of them, or it can be 20 of them, however many, a set of ordered pairs is called a relation. Think about ordered pairs like people. You can't have a relationship if there's just one person. I don't have any relationships if I'm just alone. But once there are people around more than one person, then relationships can develop. And a relationship can be shown in a table, which we'll talk about below, or a graph, which we've already talked about. So these are the examples of relations. These 4 points are a relation, and this is them on a graph. These 4 points are also a relation, and this is them on a graph. So use the, I didn't finish yet. The domain of the relation is the set of the x-coordinates. So like up here, we have 4 points. We have 4 elements of the domain. The negative 8, the negative 4, the 1, and the 5. Negative 8, negative 4, 1, and 5 make the domain, because that's all the x values for those 4. The range is the set of all the y coordinates. So the y coordinates are the second points, so negative 2, 9, negative 6, and 3. So I only use the y coordinates, which is only the second numbers in each of these for the range. So the first numbers make the domain, the second numbers make the range. So use the following ordered pairs to make a graph and a table, then identify the domain and range. So the graph hopefully is catching on pretty quickly. 2, 3. So we go over 2, 1, 2, up 3, 1, 2, 3. And I'm not going to bother well, they're not labeled anyway, but you don't have to label points in general. I was just doing that because I was learn on the others. The next point is 3, 5. So we start at the origin. We go over 3 and up 5. 4, 1. We go over 1, 2, 3, 4 and up 1. Then we have the point 5, 6. So we go over 1, 2, 3, 4, 5 and up 1, 2, 3, 4, 5, 6. So that's the graph of that relation. Now to find the table, it's truly very straightforward. The table, which looks like this, looks like a cross. It's not religious, it's just 2 lines in that form. And you put the x's on the left and the y's on the right. And you just write them just like they're showing up in the ordered pairs. So 2 is with 3, so I put 2 in the first row and 3 in the first row. 3 is paired with 5, so I put 3 here and 5 here. 4 is paired with 1, so I put 4 here and 1 here. 5 is paired with 6, so I put 5 here and 6 here. So really the table is just another way to write the ordered pairs, but it's very similar because you can see just like 2 and 3 are next to each other here, 2 and 3 are also next to each other here. Same for 4 and 1 and all the other terms. The domain, that's all the x's. So a table has already grouped it for us. So the domain is 2, 3, 4, and 5. The range is 3, 5, 1, and 6. Now some books and some teachers will ask you to put these in numerical order. So the domain was already in numerical order from least to greatest. But they might ask you to rearrange this so the smallest is first, and it goes up from there. I'm not going to be picky either way because our book goes back and forth on that, but just wanted to make you aware that that may be a requirement in a future class. And one other thing, when you're writing a domain or range, you need to make sure you're aware of. If x's or y's repeat, only list them once. In the domain and range. And I'll explain what I mean in just a moment, but go ahead and write that down. So if x's or y's repeat, only list them once in the domain and range. Now, things can repeat in ordered pairs. Things can repeat in tables. Things can repeat in graphs, but they cannot repeat in the domain and range. So first I want to make sure you see what I'm not saying. I'm not saying the same number can't show up in the x and the y, because x has 3, y has 3. That's fine. It's okay, because you need to know the domain contains 3, and so does the range. Same with 5. They both have a 5. That's fine. That's not the repeat I'm talking about. The repeat I'm talking about would be more like if I had another pair that was 3, 1. Now, if I had that as an ordered pair, I'd still put it in the table. You can repeat all you need to in the table in the ordered pairs. But if I added this point, my domain and range wouldn't change, because I've already listed that 3 is one of the elements. I don't need to list that it's there twice. It doesn't want to know how often they show up. It just wants to know what numbers are in the domain. So once I list 3 for this one, I don't need to list 3 again for this one. That would be wrong to do. Just list 3 one time. Same here with the y's. I've already listed 1 as a piece of the range, so I don't need to list it again just because 1 shows up again. So if you see repeats in the x's or in the y's, do not write those numbers twice in the domain and range.